All right, this chapter is really simple, which is why I saved it till the last thing to present for this module. Okay, so without further ado, let's get into the ANS. Okay, now it's recording, share screen. Okay, the ANS is the visceral nervous system. Okay, and it innervates smooth muscle, cardiac muscle, glands. Okay, so it is internal. Okay, the ANS is a system of motor neurons. It regulates the visceral functions, heart rate, blood pressure, digestion, urination. Okay. Okay. So now we're looking at this thing right here, and also this thing right here, the visceral nervous system. Okay. Okay. First of all, so somatic nervous system includes one neuron, one motor neuron all the way from CNS to skeletal muscle. The axons are well modulated, which means they conduct the signal very quickly and very efficiently. The autonomic nervous system is a chain of two motor neurons, so there's already a gap. That's two neurons. Okay, so that takes time. Okay, so it is slower, and also the axons are thinly modulated, so they're not quite as well modulated, so they're slower. Okay. Okay, so here. Okay, this slide has a tremendous amount of important information. Okay, so make sure you know everything that's on this slide. Okay, the divisions of PNS and CNS of the ANS breaks down into the sympathetic and parasympathetic. Okay, the sympathetic and parasympathetic innervates the same structures, but they have completely opposite effects. Okay. The sympathetic is known as the fight or flight response. The parasympathetic division controls the routine maintenance functions. Okay, so the way I like to explain what the sympathetic nervous system really is pretty simple. Imagine what would happen to you if you were being chased by a hungry tiger. Because in a lot of ways, if you guys saw the inner monkey, etc. videos, we are designed to run away from big cats, lions, tigers, leopards. All of them decide to kill us and eat us. Okay, that's what the sympathetic nervous system is actually designed for. It's not designed to freak out on tests or roller coasters. Okay, those are kind of like things going kind of haywire. Okay. 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 Sympathetic nervous system, the fight or flight response is activated during extreme situations. So exercise, excitement, emergencies. Again, this is what happens when you're being chased by a tiger. Okay. If I sat down and asked you guys what happened, you would tell me, your heart would beat faster, you would be breathing harder. Okay, your heart beats faster to get blood to your muscles faster, so you can run away from the tiger faster. You're breathing faster, so you get more oxygen to your muscles, so you can run away faster. Okay, the blood and oxygen go through your skeletal muscles, which means it goes away from your smooth muscles. Okay, you're not going to waste time digesting food when you're running from a tiger. Okay, you're going to dilate your pupils so you can see where the hell you're running off to. Your bronchioles will dilate so you can suck in oxygen faster. Okay, these are not all plus responses, right? So it inhibits the motility of the digestive tract and urinary tract. You're not going to be busy making those things when you actually are scared. Okay. Okay. The parasympathetic is the rest and digest. It's what you do, the day after your exams are over. You sit back, you relax, you drink some wine, beer, whatever your alcohol choice is, and your body is relaxed. Okay, you're more concerned with general housekeeping, so digestion, making urine, cleaning your bloodstream. Okay, your eyes are more rested, so they're not quite dilated. Your heart rate slows down. Okay, your breathing is at tidal volume, which is very, very shallow. Okay. Okay. So here is another kind of important slide. It points out exactly what happens at each organ. Okay. You realize a lot of the organs contradict each other. So like salivary glands, salivary glands is a great example. For a sympathetic nervous system, okay, you're not going to produce anything, not produce saliva, which is why when you get scared, you get dry mouth. Okay, the salivary glands for the parasympathetic, okay, you're getting ready to eat, so you need more saliva. Okay. Okay. Couple other things that are present in this picture that I want to point out. Okay. One, there's only one place where they actually work together, and that's here in the genitals. Okay. Both of them have similar intereffects, and they work together. So the parasympathetic is for erections, the sympathetic is for ejaculation. And so the way you remember this, parasympathetic starts with P, sympathetic starts with S. So parasympathetic is for pointing, sympathetic is for shooting. And you might have to explain that further. Please go back to 5th grade sex ed. All right. The other thing you can realize, you can see both neurons on here. Okay. And the parasympathetic on the side and sympathetic on the side. The parasympathetic, okay, you're resting and digesting. And that's important because if I'm resting and digesting, I have time. I can tinker with the system however I want. Okay, so I'm gonna have a long fiber here, okay, go through each individual organ, and then at each individual organ, I'm gonna have one more here so I can tinker with it exactly the way I want it. Okay, so I can modulate my responses in the parasympathetic. In my sympathetic, I do not have that much time, right? My goal is running as quickly and as far away as I possibly can in those milliseconds before I become tiger food. So what I need is to turn everything on all at once. And to turn everything on at once, I have a chain of ganglia right here, okay, where it's really, really short distance from the spinal cord. It's literally physically about maybe 1 inch, 2, okay? Then right on the side of the spinal cord, I have a sympathetic chain ganglia. The sympathetic chain ganglia then turns around and turns everything on. So if I need to flip on all the switches, I want to just go to the sympathetic chain ganglia, flip everything on, and not worry about anything else. Okay, so much longer. This light green chain, okay, or neuron, okay. This is a ganglia, right? So this is the preganglionic neuron. This is the postganglionic neuron. So the preganglionic axon here, the dark green is very short. The postganglionic axon is very long. Here is the exact opposite. The preganglionic axon is very long. The postganglionic axon is very short. Okay. Okay. They come from different areas of the CNS. The sympathetic is thoracic lumbar division. So thoracic lumbar, okay, comes from T1 all the way to L3. The parasympathetic is cranial sacral. So they either come off the cranial nerve or off the sacral nerves. Okay. Okay, so again, we cover the branching of fibers, right? So the sympathetic fibers are going to be highly branched because you want to flip on one switch to get to many organs. The sympathetic fibers are the parasympathetic fibers, so a few branches, localized effect. Okay. Okay. The both sides go to the same organs. So the only way the organ can tell these two signals apart is the neurotransmitter that's released. Okay. The sympathetic will release norepinephrine. Okay, and the parasympathetic will release acetylcholine. Okay. There are some places where you release epinephrine, but for mostly it's norepinephrine, okay? And then the parasympathetic is acetylcholine, okay? So here's the situation, okay? You guys know probably if I inject norepinephrine into the heart, your heart will beat faster. If I inject acetylcholine, your heart will beat slower, okay? And you guys are right. Now, here's the question. What will happen if I inject you guys with both at the same time, in the same place? Okay. The answer is the sympathetic will dominate. Okay. The reason the sympathetic is stronger and lasts longer. Okay. Because it's simply better to run away from a line that's not there than to not run away from a line that is there. Okay, so the sympathetic overrides the parasympathetic. Okay. All right. So we will just gloss over the rest of this. Okay. The major nerve I want to make you guys understand for the parasympathetic is cranial nerve number 10. Okay. If you look back at this picture, look at how much is innervated by cranial nerve number 10. Your heart, your lung, your liver, okay, your stomach, your pancreas, your intestines, all of that is cranial nerve number 10. Okay. Okay. So here. Okay. Cranial nerve number 10. So branches through the pulmonary plexus, cardiac, etc., etc., etc. You can see how much it is. I'm going to take this picture to show you guys the sympathetic chain ganglion. See how they're literally on the two sides of the spinal cord right there. Okay. All right. The sympathetic ganglia, blah, blah. Okay. 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 I want to focus in on one part of the sympathetic as well. Okay. and that is the adrenal medulla. The major organ of the sympathetic nervous system is the adrenal medulla. It constitutes the largest sympathetic ganglia. It secretes large quantities of norepinephrine and epinephrine, and together in that 90-10 ratio, that is adrenaline. Okay, it similarly secrete that by the preganglionic sympathetic fibers. Okay, so the adrenal medulla really is actually part of the nervous system. It's miscast as part of the endocrine system. In reality, what it is just a bunch of nervous system cells sitting there waiting to release the neurotransmitters, epinephrine and norepinephrine in very large quantities. Okay, so, and there's a lot of blood going there. So once you release norepinephrine and epinephrine into the bloodstream near you, that goes everywhere and turns everything on. Okay. All right, so the key points to this, I want to make sure you guys know the difference between sympathetic and parasympathetic. Okay, and you know, I'm asking you guys what different organs would do under sympathetic and parasympathetic, and then the differences between the two systems in terms of how long the postganglionic fibers are. Okay, what's the neurotransmitter, where does it come from, etc., etc. Okay. All right. Okay. The visceral sensory neurons monitor sensations within visceral organs. They're not quite the same as the sensory perception in the somatic system. The somatic system is much sharper. If you have a stomach ache, the stomach ache is more of a general nausea, hard to pinpoint type of deal, as opposed to being hit in the arm. You know exactly where the pain is. Okay. All right. Okay. Visceral pain. There is no pain that results when visceral organs are cut. Okay. Which is cool. The visceral pain results from chemical irritation or inflammation. Okay, so the visceral pain is often perceived to be of somatic origin. Okay, and that phenomenon is called referred pain. Okay, a referred pain, like the most obvious case of a referred pain is when you have a heart attack. One of the most common things people report is pain shooting down the arm, left arm. And the reasoning for this, okay, is basically your body is not used to your pain, your heart hurting, and sending the signal that your heart is hurting. It trips and thinks it's from somewhere else. It's like, it must be somewhere else. Well, where else can it be? Well, it has to be from the same nerve that's telling me my heart is hurting. Great. What nerve is that? Well, it's a nerve that controls the left arm. Oh, therefore, and that makes sense. The left arm does hurt from time to time. So, okay, it's pain from the left arm that I'm misinterpreting. Okay, and that is referred pain. Okay, so you can see the referred pain locations. Okay, we'll skip the rest of the chapter. Oh, one last thing. Okay, the ANS is not under direct voluntary control. So I can't sit here and go, hey, look, heart, you gotta beat faster, or you know what, you gotta beat slower. But I can influence that, and that's because these things are modulated by the CNS. Okay, so here's the overall control, but our limbic system and our cerebral cortex actually plug into this. So if I sit here and I think about waterfalls and grass and bunnies hopping down the street or whatever the hell my happy place is, then my heart rate slows down. Okay, if I show up and I think scary thoughts about my scary movies or being murdered in the street or whatever my nightmare scenario is, my heart rate goes up, right? Okay. All right. So there we go. Okay, so we'll stop right there. That was a really short presentation.